Right, welcome to our next lesson on solving one-step equations. This time we're going to work with solving multiplication and division equations. Alright, so before when we were working on solving one-step equations, that magic number that we needed to get to was 0, because 0 allows you to add or subtract without changing the identity. In this case, we're working with multiplication and division. So we have to think of what's that number that allows us to multiply and divide without changing the value of the number. In this case, that number is 1. So our magic number here is 1. So we want to try to get it so that way on one side of our equation, we're left with the variable times 1, okay, or the variable divided by 1. We're still going to use the inverse operation, where you have to look at what am I doing, what kind of equation is it, and then I have to use the inverse operation to solve. So looking at this first problem, we have a multiplication equation, and since it is a multiplication equation, we're going to use division to solve. Okay, and I want this to become 1 times a equals something. So in order to get this 9 to go from 9 to 1, I know that I have to divide by 9. And I know that what I do to one side, I have to do to the other. 9 divided by 9 is 1. 54 divided by 9 is 6. And anything times 1 is itself. So this tells me that a has to be equal to 6. If we go down to the next problem, though, we're using division. So anytime we see a problem set up and it looks like a fraction, that means division. So here I have x divided by 5 equals 10, or I can have it set up as x over 5 equals 10. Now, because it's a division problem, I'm going to use multiplication to solve. And this is confusing again when it comes to, just like when it was subtraction, where you're adding and you're not actually adding, because of the fact that the operations undo each other. So in this case, to undo the divide by 5, I have to multiply by 5. Okay? These two things will then get each other to 1. So this will become 1x is equal to, and what I have to do to one side, I do to the other. So that would be 50. So x would be equal to 50. Again, notice I'm showing my work on both sides so I can show how I'm balancing that equation. If you look at it with how a fraction works, I have x over 5 equals 10. So remember that whenever I multiply something, so this is multiplying by 5, means I'm multiplying by 5 over 1. And sometimes this helps students a little bit more, because then you have 5x over 5 is equal to 50. And these two 5's cancel each other out, so you're left with 1x equals 50 and x equals 50. Okay, because when we multiply straight across. If you want to, you can take this opportunity to stop and try these two on your own and then check your work. Otherwise, you can continue to work through it with me. So here I have a multiplication equation, so I'm going to divide both sides. And I'm multiplying by 6, so I'm going to divide both sides by 6. 18 divided by 6 is 3. 6 divided by 6 is 1. 1 times d is always going to be d. So I know that in this case, d will be equal to 3. And then I can go back and use substitution to check. I can take my 6 and substitute 3 in for d and see if that equals 18. I know 6 times 3 does equal 18, so I know my equation is correct. On this one, I'm using division, so I'm going to have to use multiplication to solve. So it's like multiplying by 2 over 1. So on this side, I would have 30 is equal to. Now these two 1's can cancel each other out because they're both divisible by 2. And I have r times 1 is r. 1 times 1 is 1, and I know anything divided by 1 is itself, so in this case 30 is equal to r. And again, I check my work. Is 30 divided by 2 equal to 15? Well, I can use long division just to triple check my work here. And I did get 15, so I know my answer is correct. All right, so on the next problem, so you're going to go ahead and you're going to try them on your own, and then when you come back, you can check your answer. So here you should have gotten that you're dividing both sides by 3. Here you would have been left with x equals 7. Okay. And then graphing it on the number line. And then here you have y divided by 9 equals 1. So y over 9, you would have to multiply both sides by 9. And this is like multiplying by 9 over 1. I know I'm running out of space here. These two 9s are both divisible by 9. So 9 divided by 9 is 1. 9 divided by 9 is 1. Y times 1 is y. 1 times 1 is 1. So y divided by 1 is 9, which means y is equal to 9. Okay, and then here I would graph the 9 by plotting a dot on there. Alright, so next what we're going to do is we're going to take our word problem, create our equation, and then we're going to solve. So here, again, we're just going to quickly look at what the question is. Did she work at her average rate? So what I need to know is, what is her average rate? Okay, and then if I look at the problem, so Juanita is scrapbooking. She usually completes about 9 pages per hour. One night, so her average rate is 9 pages in 1 hour. So then if I want to know if she worked at her average rate, I would need to know how many hours and how many pages. Alright, so 9 pages per hour is her rate. Okay, it's not an important number because it's giving us what we're looking to compare to. One night last week she completed pages 23 through 47, and that's her pages, and she did that in 2.5 hours. Okay, and rate here would be our to-do word, and a rate tells us that we're doing, in this case, pages in time. Now here, it's not that she completed 23 pages or 47, she completed pages number 47 through 23. So how many pages is that? I would have to take that 47th page and subtract 23. And I would get 7 minus 3 is 4, is 2. So she completed 24 pages. And I know that she worked for 2.5 hours. Okay. So then now what I can do is I can look and I can see if I take 2.5 and multiply it by 9, do I get 24? Okay, so 5 times 9 is 45. Carry the 4. 2 times 9 is 18, plus 4 is 22. So she would have had to complete 22.5 pages in order to have worked at her average rate. So in this case, the answer is no, she actually worked faster than her average rate because she completed more than the 22.5 pages. You could also have figured this out by taking the 24 pages that she completed and dividing it by the 2.5 hours. Okay, and if you did that, you should have come up with 9 6/10, which means she completed 9 6/10 pages per hour, which again means she worked faster. So here's another problem that you are going to go ahead and try on your own. Remember to check for your question first and then find that important information. This one might be a little bit more complicated though, so make sure that you read carefully. Set up your equation. If you want to check back and see if your equation is correct, you can do that before solving, or you can solve it all and come back and check your work. Alright, so first and foremost, the question is asking us, how many cards did Roberto give away? So it's important to note that we're looking for what he gave away. And then we know that we need to write and solve an equation to solve the problem. So a couple of things that I need to know. I need to know how many cards he had. Okay, because obviously I want to know how many he gave away. And in looking at the problem, I might need to know how many friends he gave them away to, or so on and so forth. So let's take a look at this. So Roberto is dividing his baseball cards equally between himself, his brother, and his 3 friends. Okay, so we know that he's dividing out the cards. And in this case, then, I need to know how many people did he split the cards with. And notice he said equally, but it's between himself, his brother, and his 3 friends. So 3 isn't the important number here. We have himself, his brother, and 3 friends. So he has 5 people that he split the cards with. Okay, and Roberto was left with 9 cards. Left in this case tells you what was equal, so that tells you the flip side of the equation. Alright, so I know that I'm dividing, and I don't know how many cards he had. So I'm going to let that be represented by C. So I know I can take the amount of cards that he had, that he divided by his 5 friends, okay, and he should have been left with 9 cards. So what that means is, being left with 9 cards means that he got 9 of those cards. And since he split it equally, that means everybody got 9 cards. So we know that he took the cards, he divided them by his 5 friends, and so each friend got 9. Because if he was left with 9, each friend should have gotten 9. Okay, because it says equally. So I know that to solve this, I would go ahead and I would multiply both sides by 5. And I would get C is equal to 45. But now, C represents how many cards he had started with. Okay, we want to know how many did he give away. So he started with 45 cards. He has 9, so those weren't actually given away. So now I have to use what I learned from my equation to answer the question. So since he started with 45 cards, he still has 9 left. That means he gave away 36 cards. All right, your next step is going to be to complete the guided practice. Make sure that you show all of your work. You have some extra space in your notes to make sure to be able to do so. As always, if you have any questions, please be sure to email me or write them down so we can go over them in class.